Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Now we are going to show that the sum of 8 choose k sine k theta equals to 256 cos to the power of 8 1 over 2 theta sine 4 theta. So the first step is to change the sign into the imaginary part of e to the I k theta, or z to the power of k. And then we know that 8 choose k times z to the power of k is equivalent to 1 plus 1 to the power of 8 times z plus 1 to the power of 7 times z squared dot 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 until you get z to the power of 8. And this is equivalent to the binomial expression of 1 plus z to the power of 8. And we also know that z equals to cos theta plus I sine theta. So it can then be written as imaginary part of 1 plus cos theta plus I sine theta to the power of 8. And now we are going to use some identity. So 1 plus cos theta, using double angle formula, we can change it into 2 cos squared half theta. And sine theta can be changed into 2 sine half theta cos half theta. And then we are going to factorize the 2 cos half theta out. Then we apply the De Moivre's theorem and we obtain cos 4 theta plus I sine 4 theta. And then we only want the imaginary part. So the answer is 256 cos to the power of 8 half theta times sine 4 theta, and that's our answer. We are now going to show the sum of negative 1 to the power of k times 8 choose k sine k theta. Because it is a sine, so it is the imaginary part of the e to the I k theta, or imaginary part of the z to the power of k. And then, since it is a z to the power of k, so it is also the negative z to the power of k. So imaginary part of the sum of 8 choose k times negative z to the power of k. And we have seen this identity just now. It is also the binomial expression of it, so it is 1 plus minus z to the power of 8. Alright, so we want to find imaginary part of 1 minus z to the power of 8, and converting z into cos theta plus I sin theta, we have this, and we are going to change it into its identity to further simplify it. So 1 minus cos theta, using the double angle formula, we can change it into 2 sine squared half theta, and then the sine theta can be changed into 2i sine half theta cos half theta. And then we factorize 2 sine half theta to the power of 8 out. And then we are going to change the sine half theta into cos pi over 2 minus half theta, and cos half theta into sine pi over 2 minus half theta, because we want it to be in terms of cos something plus I sine something. And then we are going to use this identity again to eliminate the negative sign. So once we have this form, we can now apply the De Moivre's theorem. So now we can times the 8 into the cos something plus I something, and we obtain cos 4 theta minus 4 pi plus I sin 4 theta minus 4 pi. And then we want the imaginary part. So the final answer is 256 times sine to the power of 8 half theta times sine 4 theta. In this example, we are going to show that the sum of k sine k theta from 0 to 5. So it is kind of impossible to find this, but we can use the derivative to solve for it. So we know that the sum of k sine k theta is the derivative of cos k theta. Because we differentiate cos, we get a negative sign. So we add a negative sign behind to maintain the equality. So from the previous example, we have found that the sum of cos k theta is sine 3 theta times cos 5 over 2 theta cosec half theta. So what we have to do is just have to differentiate this expression, and we can obtain the final answer.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions, and the mark scheme just doesn't seem to help. Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie, we'll see you next time. Bye-bye.